Graphing square roots. So to graph a square root, the first thing we have to do is find out what x values we can plug in there, and that goes back to our domain. So if you remember, the inside, this right here, must be greater than or equal to 0. That's our domain. So that means we can plug in any x value we want as long as it's greater than 0. So let's bring our function down. And then now we can plug in values. And this is where we want to start. We start with 0, and the next value would be 1. And then we could pick 2, but what's the square root of 2? It's not nice. So we pick values that we know, perfect squares in this situation. So if we plug it in, square root of 0 is 0, square root of 1 is 1, and the square root of 4 is 2. And that gives us the three values that we need that we can plot. So we're going to plot 0, 0, 1, 1, and then 4, 2. And that is the graph of our perfect square. And that's what all square roots will look like. They will all have this shape to them. So let's try another. We do the same thing. That inside right there must be greater than or equal to 0. So we're going to plug in the same values, 0, 1, and 4. But we have a different function this time. It's negative 1 plus square root of x. So the same thing happens. We plug in 0. This time we're going to do it a little bit slower. F of 0 would be negative 1 plus the square root of 0, which is negative 1. And then f of 1, and then we also need f of 4. So negative 1 plus the square root of 1, that's 0. And we get 1. So we get negative 1, 0, 1. Now it should still have exactly the same shape. So first point is 0, negative 1, 1, 0, and 4, 1. See? Exactly the same shape, it's just been moved around. So when you graph these, make sure you have that same kind of swoop. Alright, so let's do one more. So now inside, we find its domain. On this one, we're going to actually have to solve so that it's greater than or equal to 0. So greater than or equal to negative 2. So that's where we start. Negative 2, and we want greater, so negative 1 and 0. Right? So let's test them. If we don't get the right answer, or we're going to get the right answer. I'm saying if we don't get the answer we like, then we'll pick another number. Okay. So f of negative 2, that's 0. Now we do f of negative 1. Let's give ourselves some more space. That's negative square root negative 1 plus 2, which is negative square root of 1, which is negative 1. Okay, now f of 0, that's 2. I don't want to do square root of 2. So let's pick another number. So what we need is a 4 inside. So if we pick 2, that'll give us 4. We could also use 9. So if we did a 7, so f of 2, and there it is, negative 2. Now we graph it, negative 2, 0, negative 2, 0, negative 1, 1, negative 1, and then 2, negative 2, and there's our swoop. You notice it's upside down this time. And the reason is right here, the negative. If we have a negative in front of our radical, then it's going to be going in a downward motion. It's going to be flipped across the x-axis. But it's the same idea. So here are 3 problems for you to try. Find the domain, and then start with that number and find some points, 3 points within that domain, and then graph them. So hit pause, give them a shot. Alright, and these are the graphs you should have had. So you should have a domain of x is greater than or equal to 3, 0, and then greater than or equal to 2. And then after graphing them, you should have plugged those points in, which should have given you these graphs. Now if you remember the quadratics that we did, this has a shift of 3 to the right. This one's not shifting at all, but it's downward because it's negative. And this one shifts over 2 plus 3. It's the same idea with the quadratic, so that is another option.